People love the idea of an indestructible houseplant that can survive in a windowless room or a totally dark corner of an apartment. But total darkness is a biological death sentence. Every plant needs at least some light to photosynthesize and survive. When a plant survives in a dim room, it relies on shade tolerance, an evolutionary adaptation to capture and utilize soft, reflected, or indirect daylight. That adaptation keeps greenery alive in your living room, but it is also a misunderstood survival mechanism at the center of global food security. Many of our common indoor trailing vines and durable houseplants belong to a family called aroids, which originally hail from dense tropical environments. One member of this family is actively cultivated for sustenance. It's called Xanthosoma sagittifolium, or Tanya. This single shade-tolerant species is one of the world's most important tuber crops, feeding more than 400 million people worldwide. To pull that off, the plant has to generate a massive amount of biological energy to feed these entire nations, all while growing in the deep shadows of the forest floor. Tanya thrives in warm, humid tropical environments, but it actively avoids direct canopy sunlight. This diagram shows the plant's unique arrow leaf structure. The leaves have enormous surface area. It continuously pushes out 50 massive leaves. This overlapping array acts as a biological net, efficiently patching the scarce photons of light filtering through the canopy. Tanya solves the energy deficit problem of the understory by substituting light intensity with vast leaf surface area. Farmers exploit this shade tolerance through a practice called intercropping. Instead of clear-cutting forests, they use Tanya's biology to optimize their land use. Tall perennial cash crops like bananas and oil palms form the top canopy layer. Cocoa trees also require plenty of sunlight to grow, but they are vulnerable to intense afternoon exposure, which can severely damage their leaves. Farmers plant Tanya directly beneath the cocoa trees in a mutualistic arrangement, putting the otherwise dead shaded space to work. The broad leaves of Tanya act as a protective cover crop, shielding the soil from drying out and regulating the environment for the cocoa above. Shade tolerance allows farmers to stack their harvests vertically, transforming a two-dimensional plot into a three-dimensional food engine. Over its long growing cycle, the plant slowly collects energy. It stores that energy deep underground. The subterranean stem swells into a massive starchy base called a corm, surrounded by potato-sized offshoots called cormels. These are the plant's energy vaults. This chart shows the nutritional density of those cormels. They consist of 85% carbohydrates and 10% protein, making them highly efficient caloric stores. They deliver vital micronutrients to resource-poor farmers, offering a reliable source of vitamin A, vitamin C, potassium, and calcium. This dense nutritional payload is constructed entirely from the leftover waste light that the canopy crops failed to absorb. Once mature, the cormels provide a continuous harvest. Farmers can pull food from the soil over the course of 500 days, while the primary mother plant remains intact. Traditional monoculture farming demands that forests are clear-cut to create entirely exposed, sun-baked fields. Tanya offers a highly efficient alternative. After harvest, it serves local diets in a variety of ways: boiled, fried, baked, or ground into flour. Cultivating it maximizes both the economic and caloric output of small farm plots, without the need for expensive synthetic inputs or additional cleared land. Tanya's evolutionary adaptation to the dark makes it a crucial tool for sustaining populations and producing food while leaving the forest canopy intact.